Oh, The Jetsons, an animated sitcom depicting a futuristic family in 2062. That sounds about right. It was created by Hanna Barbera. Man, thanks, Hannah. Let's see. 1962 was the first air date. Wow, that's amazing. That's amazing. Yeah, so it definitely has that 1950-ish vibe to it because it was early 60s it was made. So Rosie is the robot in the Jetsons. And Rosie is a domestic housemaid. She's a domestic cleaning robot. And Rosie has she has a personality, a very like anxious personality. She, whenever there's, from what I remember, gosh, I haven't seen it since I was a kid, right? But I remember she would get, maybe if like company was coming over and she had to make a big meal, she'd get all frazzled, or or if the kids were dirty or something, she'd get all frazzled, and like a C3PO type of, just anxious. And just my favorite thing ever in the whole wide world. So, what would it take for us to have our own domestic robots like Rosie? And what I'm talking about, the elements I'm talking about here, is the robot needs to understand language. It needs to understand. It needs to understand vision, language, commands. If we talk to it, it has to have that human type of interaction, human robot interaction. Has to understand language. So we're talking like a large language model. We're talking probably a vision language action model. That's it. It can see something, it can understand something, and it can put an action to it. I mean, that's a large stack. That's a very big software stack we're talking about. And not only will it have to understand how to do it, it's got to map the home. And also it needs to be able to do all of these things on the device and not on the cloud. Because for privacy issues, people probably won't want something that's on the cloud. They want something that can work autonomously through their own device. So you don't have any privacy issues. People technically, if it's not on the cloud and it's on device, it's not open to the network, and it cannot be jailbroken into. Theoretically, it will be, but I think the chances of something that isn't open to the cloud versus something that's closed to it, you're going to have less of a chance of that. So people's minds will be at ease. So it needs to have all of this. I mean, we're talking chips, we're talking harmonic reducers, we're talking large language model, vision language action model, we're talking SLAM, which is the program, that the software that maps the rooms out. Simultaneous localization and mapping, that's what it stands for. So yeah, so to have a Rosie from the Jetsons, I mean, maybe 2062 might I'm trying to think if that sounds a little aggressive, or if that's right on point. Probably. I mean, gosh, I guess if we don't have a Rosie like robot by 2062, then something went wrong with the world. That's just what I'm gonna say. That's how I'm gonna think it. Thinking it up, guys. So to create a fully autonomous domestic robot like Rosie from the Jetsons, capable of cleaning toilets, navigating tight corners of a house, and understanding human speech without cloud connectivity, you need an advanced AI model, specialized hardware, and efficient training methods. So we're talking here, you got your SLAM, which is what I already mentioned, your simultaneous localization and mapping. It is a cornerstone technology that enables a robot to simultaneously build a map of an unknown environment and track its location within it. You're going to need some SLAM. Some SLAM, man. Like a cluttered basement, okay? In a cluttered basement with no Wi-Fi, Rosie uses SLAM to map the space in real time, dodging scattered boxes and toys while vacuuming a dusty corner. It's like, it's like anyone who walks into a new space and you're navigating a new space. Like me walking onto a new stage to do stand-up comedy, and you don't really, maybe I never saw that stage before. It's the first time I'm walking on it, but I'm doing my show while I'm navigating it. And that needs to be in the robot. And in a rural area with no internet, SLAM helps the domestic robot to navigate uneven floors and avoid furniture to clean a spilled coffee mug, all processed locally for speed. You got visual SLAM using cameras, and then you got LiDAR-based SLAM uses LiDAR. It's exactly what it sounds like. On-device processing. We're going to need some Jetson Thor. That is a chip, and that chip that costs it depends if you're talking like 800 teraflops. That's going to be upwards of $2,000 for your chip to do that SLAM. Integration with VLA. SLAM feeds spatial data to Vision VLA, which is Vision Language Action Model, enabling the robot to align maps with commands like clean under the couch while avoiding obstacles. So you're gonna need some SLAM in your domestic robot. That's gonna be like Rosie from the Jetsons. Okay, you're gonna need some SLAM. Then also you're gonna need. What else are you gonna need, Lisa? Well, you're gonna need proprioceptive sensing, inertial measurement units, that's IMUs, and joint encoders provide real-time feedback integrated with VLA models on Jetson Thor. That's another chip for smooth motion. And they use Boston Dynamics as an example here, and I want to talk about Boston Dynamics Atlas in a minute. So you're going to need some of that. You're going to need some human-robot interaction interfaces. And that's going to be another chip, man. It's going to be Jetson Thor. Jetson Thor, I'm talking NVIDIA, guys. NVIDIA, the golden standard of robot training and robot software, robot learning, navigation. You're going to need some task planning and scheduling. And we're talking hierarchical task networks or behavior trees run on device integrated with vision learning action models. You got, for example, Gemini Robotics it's called HTN. That's a hierarchical task network. So Gemini Robotics uses HTNs to schedule tasks, achieving 95% efficiency in multitask scenarios. We're getting there, guys. We're getting there. You're going to need some robust error recovery. So if your robot, your domestic robot, if its brush jams while cleaning a toilet in a cabin, error recovery triggers a retry or alternative action. So it needs to be able to recover quickly, and that's robots today are quite clunky at that, as I showed you with the robot running into the tree outside and not being able to just kind of I think birds were rumming around its head and it was dizzy. It was like, that's what was going on. It took a while to recover. So this helps it recover quickly. Robust error recovery. You're going to need some thermal management. Anything that creates heat, you're going to need something to cool that thing down. As my husband says, heat kills. And even human beings, we got our own air conditioning system to cool us down. And robots, they need that too, or they die, just like human beings. Okay. And I'm talking when you're sleeping at night, don't even think about touching. Don't even think about touching that thermometer. Okay. Don't even think about touching that thermometer. 60 degrees. 66 is best, but I will be okay with 67. Don't even go higher than that. Don't do it. And that's how I've been my entire life. Entire life, okay? And I think robots are going to they'll like 66 degrees too. They'll like cold. They like the cold. Anything that produces heat, they're going to like that cold, okay? You're going to need, all right, so besides all that, okay, I named all that. Here we go. You're gonna need vision language action model, which I already talked about, and you're gonna need that NVIDIA's Jetson Thor 800 teraflop on device. It needs to run on device. Running locally eliminates cloud latency, crucial for real-time tasks like avoiding a pet while vacuuming. You're gonna need a large language model like OpenAI, like ChatGPT on your robot. You got on-device challenge, a large language model. A large language model. We're talking Llama 7B, which is 7 billion parameters. That needs significant memory. It's too much for edge devices like Jetson Orin. So one of the solutions is, and I want you to know, an edge device, guys, that means it's running on the device. Edge computing and on-device computing are closely related concepts, but they're not identical. Edge computing often means on-device computing, especially in the context of a domestic robot like Rosie. It refers to processing data locally on the device rather than sending it to the cloud server. However, edge computing can also include nearby devices like a home hub, and so it's a broader term. Edge computing processing data close to where it's generated to reduce latency, save bandwidth, and work offline. In robotics, this usually means on-device processing to ensure fast, reliable performance. Now, on-device computing, a subset of edge computing where all processing happens directly on the device. The robot's on-board chip like NVIDIA Jetson Thor without relying on external devices or the cloud. So we're talking edge computing for this domestic robot. And again, to make a domestic robot, you're going to need a lot of things. You're going to need SLAM, the simulation, simultaneous localization and mapping. You're going to need some proprioceptive sensing. You're going to need human-robot interaction interfaces, task planning and scheduling, robust error recovery, thermal management. Then you're going to need some vision language action model. We're talking Jetson Thor 800 teraflop. You're going to need a large language model. You're going to need something like a distillation because Jetson Orin is too much. It's too much. A large language model. You're going to need more than 28 gigabytes. So something like Distilbert. That would be Googlebert. All right. You're going to need real-time action chunking in your domestic robot, which breaks complex tasks into smaller actions. This reduces computational load and ensures smooth, responsive movements. In a tight hallway corner filled with dust bunnies, the robot chunks the tasks into extend arm, sweep dust, and collect debris, avoiding furniture scratches with precise quick actions. So you're going to need some more chips for that. And then you're going to need something like Groot Mimic. Now that is NVIDIA. It uses teleported demos. We're talking a VR headset like Apple Vision Pro to create synthetic data sets. For instance, 10 demos of scrubbing a sink can generate 1,000 plus training episodes for the robot. So you're going to need that, some training, imitation learning. You're going to need some edge computing platform. I just told you what edge computing is. You got NVIDIA Jetson AGX Thor or Blackwell Architecture 800 teraflops. Supports on-device vision, learning, action, and large language model inference. Inference is the brain. It's thinking, inference. So you're going to need that. That's a hardware requirement. You're going to need some actuators and harmonic reducers. Harmonic reducers provide precise backlash-free motion for robotic arms, crucial for scrubbing tight corners or delicate tasks like polishing glassware. They're compact, fitting, a sleek humanoid design. You're going to need some sensors. You're going to need a lot of power for your domestic robot like Rosie. You're going to need some simulation and training. We're talking NVIDIA Isaac Sim and Isaac Lab. That's simulation to real, which is it incorporates physics, PHYSX, and that is NVIDIA's physics. Physics. It's a physics engine that NVIDIA incorporates into Isaac Sim so that it can learn properly how to grip things in the real world, basically. So you're going to need that. Then you're going to need some reinforcement learning and imitation learning. Reinforcement learning fine-tunes actions through trial and error, while imitation learning uses demos for faster learning. Gemini Robotics uses reinforcement learning to adapt the new furniture layouts in a home. Then you're going to need some semantic safety. Frameworks like Google's Asimov dataset ensure safe behavior, preventing the robot from damaging furniture or pets. You're going to need embodied reasoning, enabling spatial understanding so the robot adapts to a new kitchen layout in a vacation home. It's going to have to be energy efficient. Multimodal fusion combines vision, language, and tactile feedback to handle complex scenarios like cleaning a sticky countertop while avoiding a spilled drink. Woo, we are stacking up here. You're going to need some, let's see, more training. I'll just say that. All right, so that's quite a stack. All right. There's a lot that's going to go into a domestic robot like Rosie. And now let's talk cost, because that's what I'm always interested in. How much does this cost? Before we do that, let me take a sip of my coffee, because it's going to be a lot. It's going to be a lot of cash. All right. Let's talk cost here. We're talking a prototype of a Rosie-like robot. And now, real world, we have 1X Technologies Neo. And I've showed you Neo before. Neo at the NVIDIA GTC conference. Neo was pushing a stick vacuum with that tan Nehru-looking jacket, jumpsuit on. And Neo is trained on NVIDIA software. I believe Neo is a vision language transformer model. I'm not sure if it's a vision language action model, because that's quite expensive. Excuse me. Excuse me. I didn't want to burp into the microphone, guys, into your ear. Okay, so NVIDIA, I think, is a vision language transformer, I do believe. But now we got Figure, which is Brett Adcock's. That's his company, Figure. And his robots are VLAs. That's a vision language action model. And that's quite a stack. That's a very expensive stack. And it's just a little bit more efficient and not so piecemealed. So these are the real world robots doing that right now. There's other ones, of course. We were talking Boston Dynamics electric. Well, they're all electric, but their new robot, their new and improved Atlas. Atlas has been in the works for years, but it's a new and improved Atlas humanoid robot that is using a vision language action model as well. And probably Optimus, T-Bot. That would be Tesla, T-Bot, Optimus. So let's talk cost here. Total prototypes are going to be very expensive. A prototype for this is going to cost you around $86,000 to $355,300. No, that's chump change. Let me just pull down deep down into my pockets, go deep into my pockets, and just pull $355,000. Here you go. Boom. So you're going to have to understand finances. You're going to have to understand how to put together some funding. You have to understand how to work with VCs. You have to understand how to put a plan together, guys. You got to put your plan together. You got to get yourself together. Get it together, biatch. You got to get yourself all together if you want to do some sort of prototyping of any of this, because you're going to have to go out and get funding. All right. Now, mass production of these robots goes down exponentially, $10,000 to $50,000 per unit, which would be affordable for home use. And that's still pretty, $50,000. That's like a car, man. What? Who's gonna get a domestic robot instead of a car? I don't think so. It needs to come down like a lot more. It needs to do that. So, there needs to be like incentives or maybe coupons. Can I get a coupon? Can I get a coupon for 1X Technologies Neo? Hey guys. Walk into the 1X Technology Neo store. Hey guys, I have a coupon. 50% off. So that brings it down to $5,000. Let me dig down deep into my pockets. And $5,000. Here you go. So all I'm saying is it's going to take a while. The robots are a bit clunky right now, but that's not to say there's a lot of people working on them. There's a lot of people working on different components of them. As you saw in Philadelphia with the Philadelphia company, they're just working on a hand. There's a lot of companies that are just working on a foot. They got that orthopedic thing going on. They're working on a foot. They're working on some distal parts of the robot's body. Some companies are just working on the arm, the forearm, the bicep, arm part, the shoulder, the neck, to hold the robot head up, just a robot head. There's some companies just working on a robot head. There's some companies just working on like just the little fibers. They want to make a robot look just like us. I showed you that one by Clone Robotics. The one looks like it's hanging on a meat hook off the ceiling. Good Lord. Using these like myofiber things. So there's a lot of different companies focusing on many different parts of a humanoid. So they'll all come together one day, and the software will all come together. Right now it's like the AI agents. It's just all clunky all over the place. But I would say, though, in 20, 30 years, is going to be a conversation of, is AI, will AI and robots be taking over a lot of jobs? And it's probably, so it is something to think about. Like if you are going to college, you have a kid who is a teenager or a tween, get them started on coding, get them started on understanding these things right now. And I don't mean to preach. That's just what I would do. And because here's the thing, you don't want your kid going to college for something you can learn on an app. Okay, that's a problem. They're going to screw themselves over. And so right there, just don't let that happen. And then also, if they are going to college for something someone can't learn on an app yet, but you can learn on an app in like 5 or 10 years, well, that's a problem because you want to have your job for a very, 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 very long time. So you want to keep that in mind too. Is, what can I learn today that will still be around in like 20, 30 years. You got to stay fluid. Stay fluid out there, folks. So there's just a lot of components that go, well, I was going to just wrap this puppy up. There's a lot of components that will go into a domestic robot like Rosie from the Jetsons. A robot that cleans your house, chats with you, and works offline like a smartphone with arms. It sees dirt in your basement, hears clean it, and scrubs without the internet. How will it work? Cameras spot the messes, AI understands commands and precise motors, clean tight corners. It's trained in virtual homes to handle real ones like a cluttered garage. No Wi-Fi needed, so it works in a remote cabin or during a storm. It's fast, private, and learns on the go like a super smart maid. So that's basically to wrap that up. And stay tuned, Earth. Stay tuned. We'll stay tuned on that.